All right, Jabak, will you give me that problem so that I write it down correctly?
Find h prime of x for h of x equals 3x squared plus 2 radical x over x.
Oh, okay.
Well, the entire thing's over.
Oh, the whole thing's over x. Okay. All right, so let's take a look at this one. A couple of things we could do. We could use the quotient rule. All right, but I think I want to simplify a little bit before I do that. So I have 3x squared plus 2x to the 1/2 all over x, okay? I'm going to divide, since it's just a monomial on the bottom, I'm going to divide each thing in the numerator by x, okay? So if I do that, it's going to give me 3x squared over x plus 2x to the 1/2 over x. And then if I simplify, that's going to leave me with 3x plus 2 over x to the 1/2, because we would subtract the exponents, okay? And so then before I do my derivative, 3x plus 2x to the negative 1/2. I'm going to rewrite it like that. So now I can use the power rule, okay, instead of having to use the quotient rule on that one. And so if we do that, derivative of 3x would just be 3. 2x to the negative 1/2. If I take a negative 1/2 times 2, that's going to give me a negative 1. So I'm going to change that plus to a minus. So minus 2 times the negative 1/2 is negative 1. X, I'm going to subtract 1. So negative 1/2 minus 1 would be negative 3/2. And I'm pretty sure the answer key probably said this. 3 minus 1 over the square root of x cubed. Or it might have had some other variation thereof. But, yeah. Okay? You sure?
Yeah, I went off the rails and I ended up getting 18 over x squared. But
Okay. Yeah, this one, because it's going to get really nasty in the quotient rule right here with this x to the 1/2, and your exponents are going to get berserk, okay? So I think this one's better to split it to start and then do it with the power rule.
yeah, I think that's right.
Yeah, because you could do the quotient rule, and if you want me to do it, I'll do it with the quotient rule. Okay, all right, so let's do that same one with the quotient rule. So we've got h of x is equal to 3x plus 2 square root of x, or 3x squared, over x, right? Okay, so I am going to rewrite that because I know I'm going to have to do that Hody high stuff. Just so that I've got it as x to the 1/2. Okay, so let's process through and see where our simplification stuff comes in. All right, so d high, so derivative of the top is going to be 6x plus x to the negative 1/2 minus high d ho, so 3x squared plus 2x to the 1/2. Derivative of x would just be 1 over ho, so x squared, okay? It's going to take a lot of simplification. And so let's do that. If I take x squared times this parenthesis, or x times that parenthesis, I'm going to get 6x squared plus 1 plus a negative 1/2 will be x to the 1/2 minus 3x squared minus 2x to the 1/2, all divided by x squared. Okay, and we simplify again. That's going to give me my x squares. It's going to give me 3x squared minus x to the 1/2. And we divide it by x squared. And then to make it look like the answer I got a few minutes ago, we're going to divide x squared into both of those. Okay, and so if I do that, that's going to give me 3 minus 2 minus a half will be 3/2. 1 over x to the 3/2, which is what I got a few minutes ago. Okay, so yeah, it will work out the same. You just have to do a little bit more algebra, but everything stays positive if you like positive exponents. Okay, all right, but it should work out the same. Okay, all right, good question. All right, using that quotient rule. All right, quotient and product will be the last things that are on your quiz tomorrow. So we'll cover our sine, cosine, e to the x, ln of x, general power rule, product quotient. Okay, it will not cover what we're going to do today. Okay, anything else? Okay, awesome. All right, well, let's take a look. Oh, that's not what I wanted to do. Let's take a look at, I'm going to delete some pages. Hang on, I'm going to delete this one. Delete. And then I'm going to move this one. Thank you. Right there. And I'm going to go to that one. Done. Okay, so let's go back and look at our warm-up real fast. All right, so it's a quotient rule. All right, it is multiple choice. Pulled that from AP Classroom, just something you could see there. All right, to practice. Okay, so let's give it a shot. Sine of x over e to the x. They want me to find f prime. Okay, they want me to find f prime. Which rule are we going to have to use? Quotient rule. It's a quotient. So let's start it. Okay. Ho d high. So e to the x. And what's the derivative of sine? Cosine. Okay. Minus high d ho. So sine x times e to the x. Over ho ho. So e to the x, the whole thing squared. All right. Now this is where it's going to get a little weird. All right, is in the simplification. Because if we do that, I've got an e to the x cosine minus e to the x sine over, what's that going to be on the bottom? Exponent rules right there. E to the 2x. Okay. And so one of the things that I notice is that I can actually factor out an e to the x on the numerator. So I have e to the x cosine x minus sine x over e to the 2x. Okay, what are we going to be able to do with those e to the x's? Subtract the exponents, okay? So 2x minus x is going to leave me with cosine x minus sine x on the top. On the bottom, e to the 2x minus e to the x is e to the x, so it would be b. Okay, so that one, the tough part of that one was in the simplification. And our simplification on that one. Okay, so here's our quote for today. The expert in anything was once a beginner. Everybody's a beginner at some point. All right, so today we're going to talk about using or finding those derivative rules for the remaining trig functions, right? We've done sine and cosine, and so now we're going to get into tangent and cotangent and secant and cosecant. Like, what are those derivatives? And then using those within all of our other problems. So here's what I want you to do. There is a chart there that I need you to fill out. Some of these you're going to already know, and then some it's going to ask you to work through some things, all right, to get there. So all the other things that we're working on right now, let's put that away and let's do calculus right now. Okay. All right, so I'll need you working on this chart. It goes page 1 and page 2. All right, so just 2 questions, but it asks you to kind of derive some things. It's going to ask you to use, do a manual calculation and then to also do some numerical derivatives with your calculator. So let's take a second and work through this chart with your table mates.
I don't do the trick, I just mark.
Because I know 6 is closer to the x-axis and 3 is
Okay,
closer to the
yeah.
y.
Attendance in.
Yes.
This is very high, right?
Minus which is sine minus sine times negative sine.
Cosine would be. So cosine
I started wrong.
Yeah.
Sorry.
the derivative so in this case.
Yeah,
yeah.
yeah.
So it's cosine squared. So you click on sine, and then whenever it says x, that's true.
So if we separate that out, cosine squared. Sine squared. Which is not, isn't that just tangent squared?
So the 1 plus 2.
Yes.
Oh my gosh. Let's see if it comes in sweet.
So each prime theta equals squared of, let's see if that's correct. Math 8. What number is it? 5 or 6.
Oh, maybe.
One and a third.
Y'all know how to do these, did y'all learn? Like, I know how to do it. That would be like,
Sorry.
tangent is.
Tangent is
The meaning of that would be.
Or
cosine.
1.
Yeah, one hour.
position x?
Trying to do.
Oh, yeah.
Yeah.
And just that's what we do. Right now.
Oh my gosh.
Oh, no, he's cosine and then the derivative of cosine.
Yeah.
So
that is sine?
Second.
Yes. And then
Yeah.
the derivative of cosine
Is negative sine.
Cotangent is.
Yeah,
Yes.
people negative sign squared minus cos x over sine squared.
Oh, wait, that's not.
So one minus.
Negative one
Yeah, you're right.
minus.
Oh, we're supposed to, I was supposed to have the derivative.
Yeah.
Oh, no, are you checking that or am I?
And then wait, let me figure. 5/6 sine, but then it'll be negative sine, right?
Good question. One over cosine.
That's awful.
Come on.
Let's just cancel.
And then one cosine.
The derivative of 1 is 0. Or is it undefined?
Zero, right? The derivative of one is zero.
Mm-hmm.
It's not just one. Okay, cool. One of them, sorry.
You know that means?
Yeah, and you got pineapple, strawberry, cocoa, did y'all see the last one? That. No, I know, but.
No.
So you just sign up for sign to do that? No, I'm actually.
You did that code the I part out, but it would be high code. Right,
Not
like
sure.
the
So it's gonna be sine.
Okay, cool.
secant theta, it would be sine x over cosine squared.
No.
In theta, in theta, it's gonna be sine. What do you?
I'm just trying to find a derivative, but X.
Yeah.
Is that what you're talking about?
Yes, exactly, I just said that.
Oh, that's.
Yeah, yeah.
Okay, so.
I got,
Secant is whatever cosine. Yeah.
I got sine x over cosine squared.
Yes, that's what I got as well.
Because for the sine.
Why are we doing tiny derivative?
Because
Oh,
that's
is that
over
what-
cosine. I know what I'm doing.
So it's a quotient rule.
Oh, to make a oh, guys, you're so smart. I'm so stupid.
So then, you do it, and would you split the cosine square and bottom, or would you keep it and just plug in another answer?
And then this one's gonna be right.
It's pretty close.
It's close enough.
We're absolutely so we should which is that's
Yeah, because it's.
squared plus
Yeah, minus sine over.
Where do you get sine square from?
Is there a way? Is there a way to like cosine squared or something?
times derivative of the bottom, which is negative sin x.
Cosine squared, I would think
Squared, okay.
I mean, it kind of works.
Okay.
So that would just be, wait, are you doing Heidi Ho or Hody High?
Starts with the bottom and derivative.
Yeah.
Yep.
So that's cosine times negative sine.
Exactly.
Yes, I don't know.
Times cosine. Oh, okay.
Oh, you're talking about
One plug here and one
It's the inverse.
Okay, and then that's again, top.
or cosine squared x plus sine squared x over cosine.
Yeah, just make it more complicated.
I said that. I don't know, you guys keep saying words.
And then like, so like, cosine is like she gets
It's like I
sine.
can't
So one of the
see it in my
sines
head.
for sine minus square and theta is the derivative, so.
I'm sweating, guys. Wait, slow down. I'm sweating. Okay. Wait, I have H of X is on the top.
yes.
Okay.
No.
It's sine.
Check your cosine. Well, no.
Yes, no.
On the top.
Cosine?
Not over, not over.
Negative sign.
Well, don't look at me.
And then the side.
What if you pick the square root?
Cosine.
I think that would be right. So equalize that in. Or. Any of this.
Because of the.
Sine squared over cosine squared is.
You should follow that.
How do they do this? Oh my gosh. Wait, so.
You just need the top.
But wait, cosine is negative sign. You have to put. Yeah.
Yeah, obviously. You have to do the bottom half of it.
Oh, well, yeah.
So now,
Yeah.
So I was thinking
That seems like an easier way to do.
Yeah, it's sine squared cosine.
I guess it's just one over.
That's all they got. They got one plus. You said one plus sign.
One cross tangent.
So we get that.
You're missing the one, but. You don't need it. So if you
Oh,
have
okay,
cosine squared,
okay, I got
cosine
you.
squared.
Yeah, okay, I got you, yeah, I got you.
Oh, I see
I
what
was
you
waiting
did.
to see.
Negative. So on the
Yeah, check it
bottom,
out. So one.
it's negative out of two.
That's really great. So then.
So it's like that. Just kidding. I love it.
I honestly don't know if it'd be.
Isn't it just okay? I woke up at 1 AM yesterday from the farm. I had to extinguish like the oven. Are you sure? JK. I think so. It's not good. One half.
I didn't.
This is where one quarter is over one. Yeah, right.
It came from that. Well, it's the same thing that I got. Oh yeah, you could do that. I just want to request you for that. Yeah, if you use three guys, so
One over.
Dude, especially if you use memorized.
Yes.
One over.
They're not that bad.
They're not, but it's just a lot right off the
I
bat.
think we memorized the things from last year.
Oh, I feel like memorizing the trig derivatives
You're so real
is
for
not
that.
as bad as a
You're
lot
like
of other
so
stuff
real.
people do in calculus.
That is
No, wait,
true.
that's so easy, dude.
What?
For tangent?
Oh, please.
Did you?
Okay.
Okay, so for tangent,
Right.
yeah.
Yes. Instead of doing it the way we did, right, you use the trig identity on top. So you get
So
one
you do
over.
cosine of
Also,
6.
secant.
Sort of 3 over. Where is it?
So you only have one over one.
I love my job.
I'm just watching me.
You're so
It's
smart.
terrible, it's terrible.
Neve's doing good. She missed the whole Hody High thing yesterday.
Okay,
I don't
whatever.
like the Hody High. It
Ooh,
just
I
makes-
love it.
It just makes me think of the Seven Dwarfs and then I can't do math.
You'd get -1 for B.
I'm slow.
Victory!
Negative.
It's like winning the Sudoku puzzle or the Wordle. Yeah, it's good. You're gonna make it though. I believe in you.
Cosine? Minus
I don't care. It's one
negative.
Tim's so smart.
What
Cotangent.
about this cosine squared?
I'm glad to be a.
But you would still be.
Oh.
Yeah.
You can't.
Yeah.
I'm like, oh,
So yeah,
look at it. That was funny.
Wait, pause. What?
right, yeah.
So.
Cotangent is what? Oh, duh, sorry.
That's what everyone is saying. Yeah, I'm sorry. Take it.
Word. Can we by any chance just go back when?
Cause I'm on the bottom.
I didn't do no.
If I built the time machine long enough that and I accidentally stepped on it,
What?
That escalated quickly.
I said
I think that's a good idea.
I accidentally.
Was that it?
Yeah, if it happens, it happens.
No, that we wouldn't be here right now.
Exactly.
Like, I love baking, but like,
But then also have a rope.
I mean, it's
They
also.
have a rope.
No.
they would have what?
Cause the engineering, so they get
All right, we should have gotten the first two real simple. We get those. Those are ones we've already done, right? Okay, it's when we flip over to those last four that it gets interesting, right? Yep. All right, so let's mess with it a little bit. Okay, so we're going to have to do this work, right? I would start by redefining tangent, right? How do we define tangent? Sine over cosine, okay? Those are two derivatives. Oh, you're having a good moment right there. Okay, so then we could take a derivative. We'd have to use the quotient rule, right? Because we've got the quotient of two functions right there. So h prime at theta, all right, ho d high, so cosine, derivative of sine would be cosine, minus high d ho, so sine, and then derivative of cosine would be negative sine. Okay. All over the bottom squared, so cosine squared. Okay. Let's simplify a little bit. So that's going to give me cosine squared plus sine squared over cosine squared. Right? Look for a trig identity. Do you see one? Yeah, 1 over cosine squared, which is the same thing as secant squared. Okay, so h prime at theta is secant squared. Okay, if we plug in pi over 6 and we work through that, you should get 4/3 or 1 1/3. And then your decimal 1.333. Okay, so using trig identities is going to help you on those. All right, let's do the same thing with cotangent. Talk about how it's the same, how it's different. We just end up with cosine over sine. And so again, using that quotient rule, all right, ho d high, so sine, derivative of cosine is negative sine, minus high, d ho, derivative of sine is cosine, all over ho ho. Okay. And so that's going to leave me with a negative sine squared minus a cosine squared all over a sine squared. And we're close. All right. My trig identity, could I factor out a -1 in that numerator? Yep. If I do that, that leaves me with sine squared plus cosine squared, which we know is 1, over sine squared, which would give me -1 over sine squared. So what's k prime going to be? Negative secant squared. I mean, negative cosecant squared, sorry. Okay. And if we plug in our value, we should get -4 and then 4.000, -4.000. Okay. All right. So trig identities, they're helpful. Okay, they're helpful. Let's talk about secant. This one might be a little bit more challenging. How could we define secant? 1 over cosine. Now, that's still a quotient, all right? We're going to get some unusual things in the process, but m prime. Okay, let's just walk through it. Ho d high. So Cosine derivative of 1 would just be what?
0.
0. Okay, minus Heidi ho, so 1 and derivative cosine, negative sine, over cosine squared. Okay, if we simplify that, that's going to leave me just sine theta on the top over cosine squared. Okay, now we're going to have to mess with this a little bit to see if we can simplify, all right? Because right now I'm not seeing anything that's really going to help me. But this is legal, right? In order to have a cosine squared, I had to have a sine theta over cosine theta and a 1 over cosine theta. That would get me all the things if I was multiplying, okay? So sine theta, cosine theta is the same thing as what? Tangent, all right? And 1 over cosine is the same thing as what? Secant, what we started with. And so m prime at theta is going to be secant tan. Okay, so we just use that property of fraction multiplication, all right, for secant and tan. We just simplified it, right? And then if I plug in pi over 6, it should give me 2/3 and then 0.666. If it makes you happier, put a 7 there. Okay. All right. But again, just using the quotient rules will all we're doing. Okay. So now see if you can do cosecant real fast. Okay. So see if you can do the cosecant one real fast. They have the play. Brick-a-lag.
Break a leg, oh my gosh, break a leg. Bye, Sam.
I've got to stop messing with it. Yes, just get you a pass. Don't come back with a drink.
If you do, you should chug it real quick.
I think that would defeat the purpose of going to the bathroom because then you have to go again.
You can avoid it for a while.
Oh yeah, it has a leaderboard update.
The people that went the most.
Yeah, I already read.
But it was literally like they didn't break any rules. They just used all of their passes every single.
Oh, yeah. Every time they send out a thing that's like, oh, look, these people used all these passes. I mean, they were allowed those passes, so.
Has there been an update on that?
No, they send it out every so often, but we've not had an update.
I'll be forgetting Kelly.
I feel like there should just be like, who has used.
I mean, I have a built-in potty break in my third, and that helps a ton.
You don't have to create a pass. Just the code.
No, I needed them to be on time from lunch, and that's always I was in the bathroom, and then it is hard, like coming back from lunch to tinkle because everybody's in the bathroom doing whatever. So I'm like, just get in here on time from lunch. Then once the hall clears, when the bell rings, like 2 minutes after the bell, then everybody needs to go to the bathroom. Go to the bathroom, and so then we come back, which is nice, you know. And then I have a few kids who will ask to go later because apparently they need to do their business in private. So. But it's always after I finish the lesson. Like, they don't leave while I'm teaching, and so I'm cool with that. Yeah, I'm cool. I mean, sometimes you just got to go. You know, it is what it is. All right, so let's check this one. So cosecant, we would start with 1 over sine. Oh, and if you watch any of those AP Classroom videos, I think this is where they taught, there's a lady, she says secant, cosecant. I just can't do that. It's a secant. But anyway, I just think it's interesting. I can't remember where she's from. But they say secant, and I was like, what? Anyway, all right, so let's start. Let's do a quotient. Yeah. So here we go. All right, Hody high. So sine theta times 0 minus Heidi ho. So 1 times cosine over ho ho. So sine squared. All right. And so then that's going to leave me with a negative cosine over sine squared. Oh. And then if we separate that, that would leave me a negative 1 over sine times cosine over sine. Okay, so just separating that with our trig identities. And so then that leaves me with p prime of theta is going to equal a negative cosecant and a cotangent. Okay, and if we simplified that all out, okay, you should have gotten negative 2 square roots of 3, and then that would have left you with negative 3.464. Okay. So just using your trig identities. Now, could you take the time and derive that every time? Sure, all right, but you really don't have time for that, okay? We really have to know all of these trig derivatives. That third column, we got to know those. Okay. But there is a little bit of a trick.
Pardon the interruption. Seniors' last names A, B, and C, A through C, to the library with your iPads, please.
Everybody?
I think if you've done everything, you'll get to come right back.
What is everything?
Applied, Tennessee Promise, all that stuff. Then you're
I
good.
didn't get my little treat for doing it. Were we supposed to already?
No, I think it's coming.
They used to be smarter back in the day.
I did.
2 dudes said they came up with it.
Wait, does this mean I'm not calling this out on either Quizlet or economics?
Yeah,
No, it's because everyone comes to go.
yeah.
Oh, yeah, thank God.
But you get to come back quicker if you've done everything. Sorry. All right, so it says,
Hey, go do your test.
Yeah, I did it when you told us.
that's all right. Imagine that. So what do you notice about the ones that all start with co, like cosine, cotangent, cosecant? What's true about all their derivatives?
They contain themselves, or they
They
contain
have
a
cosecant.
Well, 2 of them contain themselves. Cotangent doesn't. but
Right,
it's-
cotangent doesn't contain itself. But cosine, what was cosine? Derivative of cosine is negative sine. Derivative of cotangent is negative cosecant squared. And derivative of cosecant, negative cosecant cotangent. What do all 3 of those have? A negative, okay? All of our co-functions start with a negative. Okay?
No way it was that fast.
They're in and out, in and out.
Okay, their derivative is going to start with a negative. And that's one way to help you remember. All of your co-derivatives, all right, have negatives in front. Okay. Okay.
You guys walk out.
Change your mind. Did you change your mind?
I did it.
Oh, okay. Oh, so you agree?
Was that what you were Oh, you don't round.
Oh.
All right, so with those, all right, cosine, cotangent, cosecant, all of their derivatives are going to start with a negative. You were my last one out, weren't you? Will you shut the door? Yeah. Thanks. You okay?
I just cut my finger.
Oh, sorry. Okay, so that's important to remember. So let's write them all down in one spot. This would be good stuff to go on your reference page.
I keep reminding myself I need to update.
You do. You need to go through and update it. Okay. All right, so the derivative of sine is cosine. Derivative of cosine is negative sine. So these are all of our trig derivatives. Okay. Derivative of tangent, secant squared. All right. Derivative of cotangent, negative cosecant squared. All right. Derivative of secant is secant tan. Derivative of cosecant is negative cosecant cotan. Okay, so all the ones on the co-side have negatives in front of their derivatives. You got to know those. Got it. The only two you have to know for your quiz tomorrow are the top two. Okay, so give you some, you don't need to know all the rest until you get to the actual test day. Next Tuesday. It is so close. All righty, so now let's practice them. All right, lots of different examples, combining all the different things that we know how to take the derivative of now, and working through them. Okay. Are there things we can do to help ourselves? What's our best strategy? All the good things. With strawberry lemonade today. It's very good. Keeping it simple. Okay, rock and roll. Here we go. All right, let's look at this bad boy. All right, ask me to find the derivative u is equal to cosine over 1 minus sine. Okay, so we've got some trig functions in there. What are we going to have to do with this one? Quotient rule. Okay, it is a rational function. We've got multiple things in the denominator, so we're going to have to do quotient rule. So here we go. All right, u prime. Ho, 1 minus sine x. D high, derivative of cosine, negative sine. Okay, minus high, so cosine. Derivative of the bottom, so high d ho. Derivative of 1 would be 0. Derivative of a negative sign would be a negative cosine. All divided by 1 minus sine, and we're going to square the whole thing. Don't multiply out the bottom. All right, the hope is eventually we'll get to something we can reduce. Okay, let's do multiply out the top. So we're going to have to distribute. Okay, so this is going to give me a negative sine x plus sine squared. That's going to give me a plus cosine squared over 1 minus sine x quantity squared. Okay, this is where we look for trig identities. Can I simplify things? All right, do you see anything up there that's a trig identity? Sine squared plus cosine squared is equal to 1. So I have 1 minus sine over 1 minus sine, the whole thing squared. Okay, what are we now going to be able to do? Yeah, we're going to be able to reduce 1, all right, because that whole numerator is in the denominator, all right? There's 1 on the top, there's 2 on the bottom. It's going to leave me 1 on the bottom. So 1 over 1 minus sine x is my derivative. Okay, so using all that trig yet again. Y'all know I love trig, right? So does the AP exam. Just so you know. What'd you say?
Hopefully Trevor clicks with this test.
Who's Trevor?
Trevor Packer.
He's the
the head of the AP program.
Yeah, he's the head of the college board.
What a cool job that was.
Yeah, except during COVID, it was terrible. God love him, he was forever putting out fires during COVID. We took our AP exam at home that year.
Huh?
We took our AP exams at home that year. It was 2 questions, all free response. They both had like A through G parts, or A through H, and they had 45 minutes per question.
So how did they do? Did they win? I mean,
Did they win?
Good.
Some did. We got to challenge a few scores. Like, it was weird because I had somebody that I was pretty sure was gonna pass, right? I thought he would make a 4. He got a 2. So we had them rescore his. But then I had kids whose technology didn't work, and so they got to redo it. And one of them got to redo it twice. Now, it was a different test every time. And he got a 4. And God love him, he was the slowest kid in class. So I don't, he just didn't catch on as quick as everybody else, So I don't know if he used his extra time to prepare and study, which he may have done. His grandfather was one of my professors in college. So he had an inside source, just some extra help. I don't know. But anyway.
Bro, Miss Moore, how are we gonna do this test online?
Oh, the multiple choice is online, just like how you do your progress checks. Okay? So, and I don't know if you'll get to go back and look at things, but I think you get scratch paper. Oh, yeah. You get scratch paper. The free response, you will see them on the screen, but you will still write your answers in a booklet. Okay, yeah. Yeah, because when they did their free response at home, they had to write it on paper, take a picture, and upload it. So they had to allow time for that as well.
What the heck?
We don't get to take the easy version of the ACT.
I know.
Wait, so will we take the AP test on our iPads? Or
That is my thought process, is you will do it on an iPad. Yeah. So I don't know, but I'm not sure. But there will be a lockdown browser. Like, there will be, when you use the Bluetooth, it's called Blue something. Blue Book. It locks down everything. So we're going to have to practice with that. I'm sure there's some testing that we'll have to do, because we still can't test all of you that are going to test in the building. Like, we're going to have to do it across town at the church. So make sure their Wi-Fi is capable and all that stuff. So there's just a lot that goes into it.
Our test day isn't on anything else.
No. Well, pre-cal is the same day. Y'all are morning, their afternoon. It's May 12th. It's Monday.
We're morning.
Your morning.
Yeah.
How do you challenge a score? By, what?
They gave us the option to have it rescored. So we could challenge anything. That year was the only year we were allowed open challenge. So we asked them to rescore, but they said that's what it was. But then we got every test version. So like that my kids took, and there were like bukus of versions. So I think I only had 13 kids that year, and I got copies, and I still have them of all 13 of their tests and their responses, which never happens because they knew we were never going to do this again. Like more than likely. Yeah. It was bizarre. I had one student who just didn't log in and take it. So, because, we were asking people to come to Zooms. We were asking people, the good news for us is they stopped curriculum, and I had already covered everything from where they stopped. So we got to review from the moment we went out for spring break for COVID until they took the test the 1st of June. So that was good, but it was on them to review, and it was just too long. There was too much of a time span because, like I said, I'd already covered everything. So, and they did daily, reteaching videos. That's when AP Live came about. And they were fantastic. I became best friends with Verge. I really think she and I could be besties. But she was the lady that taught me. So, one of the reasons I want to go grade, because she's ahead person for that, and I just want to meet her. I did. She had purple hair at the time. She's about my age. Her kids are about Becca's age. Anyway.
I feel like if I saw Heimler,
Oh, we
Oh
all
my
were
God.
amazing. Heimler, oh my God, he carried me in April.
Oh, I want to meet Heimler.
we should take a trip to Jordan and try to find him.
Oh my god.
All right, try this next one. Equation of a tangent line. Okay.
Actually hunting down Heimler.
Yeah, today I found out that he has videos from macroeconomics. No, crazy.
Bro.
Alright, I forgot.
Y'all think Geo?
I didn't take Geo.
He didn't invite me.
I declined.
Yeah, I declined.
I took
Yeah, I asked to get.
Y'all are
said
all
take advantage.
boring.
I still have second.
Geo was, I mean.
You know what? I took Geo, and so I didn't have to take Ms. Fox's class, and
Oh,
I
you
didn't
did
have to
take
take
Geo.
wellness because I went and did
No,
other.
I'm not taking
Fingers
Fox's
crossed.
class because your mom complained.
No, I didn't have to take Ms. Fox's class.
I am
because
recording,
Ms.
I'm just
Fox's
saying.
class conflicted with
You know what, Solomon?
Hoover's class, and so they tried to put me in the standard physical science class.
Yeah, that's not, that would have been a no-go.
Then
That would have been a no-go.
Yeah.
I'll go with you on that one, Gareth. That would have been a no-go. All right, when we write a tangent line, what do we need? Slope and a point, okay? How do we get the slope? It's the derivative, okay? The slope of the tangent is the derivative. So derivative of sine would be cosine. Derivative of 3 would be 0. And then we're going to evaluate that at pi. So the cosine at pi is -1, okay? We also need a y value. We know the x value of my ordered pair, but we need the y value. So we're going to plug that value in for y, which would be the sine of pi plus 3. What's the sine at pi? That's 0. And so it would leave me with 3. So I have my slope now and I have my point. So my tangent equation, y equals negative x minus pi in parentheses and then plus 3. Leave it that way. Okay? All right, so there's always going to be a tangent problem. You can count on it. Okay, if not multiples of that. But let's go to this next one. And I don't know what that extra mark is. Probably looks like my cursor from when I screenshot this from something else. All right, so find the derivative of f of x equals 3 cotangent plus the natural log of x times cosecant. So we're going to have to combine a few things, okay? When I look at this second term, it is actually a product. So we're going to have to use product rule on this piece. Okay, so it's going to be combined within everything else. The cotangent, I'm just going to be able to use my cotangent formula, all right? So here we go, f prime of x, all right? The 3 is a coefficient, it's going to stay. What's the derivative of cotangent? Okay, it's negative cosecant squared. It's a co, so it's going to be a negative, okay? So negative 3 cosecant squared. Now, I'm going to keep that plus, and let's do this product rule, okay? Product rule says you take the first times the derivative of the second. Derivative cosecant is negative cosecant cotangent, right? Then we're going to do plus second, so cosecant, times derivative of the first. What's the derivative of ln? 1 over x, okay? Now, I'm just going to try to simplify where I can. So I have negative 3 cosecant squared minus the natural log of x times cosecant cotangent plus cosecant all divided by x, all right? And I'd like to tell you there's some nice fancy simplification to that, but there's not. Okay, it is what it is. All right, I could pull a cosecant out of everything, but it's not going to help me any. All right, because everything's got a cosecant, so that doesn't help me because it doesn't leave me with something I could reduce. All right, it's nasty, but it is what it is. Okay. All right, let's do a couple more. All right, so just like to show you different degrees of difficulty. All right, let's look at this one. Ooh. Okay. 7 divided by 5 secant x. Right? 7 divided by 5 secant x. Okay. We could quotient rule, agreed? All right. But we could also simplify this a little bit with some trig. Okay, so watch what I'm going to do. How do we define secant? Yep. So this is the same thing as 7 divided by 5 over cosine. Okay. So do you agree that I could rewrite that as 7 times cosine divided by 5? Yep. So this function is really 7/5 cosine of x, which is a much simpler derivative to take than using that quotient rule with a secant. Okay, so recognizing that. So now if I take the derivative, keep my 7/5, what's derivative of cosine? Negative sign, and that's my answer. Okay, so recognizing those trig identities in there, if you can make it simpler, it's always a good idea. Okay. All right, let's look at the next one. All right, as with all quotients, if I have a single term in the denominator, could I divide both things in the numerator and make it something easier? Okay, it's worth a shot. All right, you could still do quotient rule here, but you're going to end up with a butt ton of trig functions and identities that you're going to have to use. Okay, so let's mess with it a little bit. All right, so if I take tangent and I divide it by secant plus 4 over secant. Okay, so it doesn't look like it's helped me yet, but how do I define tangent? Sine over cosine divided by, and secant, 1 over cosine. Okay, so I'm just rewriting them. And then 4 over 1 over cosine. All right. If we simplify that again, all right, that's going to give me sine over cosine times cosine over 1 plus 4 times cosine over 1. We're going to be able to simplify quite a bit, okay, and make this much nicer. So my whole problem actually works out to be just sine plus 4 cosine, all right? So my original function would simplify to that. So now when I take a derivative, it's much easier, okay? I can use those basics. So g prime at x would equal derivative of sine would be cosine. And then derivative of 4 cosine would be negative 4 sine. Okay, so we can do our hard work on the front end or we can do it on the back end. But I'd rather take an easier derivative. That's just me. Okay, so remember, with any quotient, if it's a monomial on the bottom, you can simplify it. Okay, you can simplify to start, and it should make your process a little bit smoother. Okay. I think this one's the worst one, or maybe the next one, but I'm pretty sure it's this one. Okay, because I'm not going to be able to avoid the quotient rule on the next one. Okay, I'm not going to be able to avoid it. Yep. You want me to walk through it with you? Or do you want to try first? Okay, y'all try first. If you can't get all the simplification, that's okay. Just see if you can get all the right pieces for the derivative. Okay, so start there. Okay, did you get that for your first line? Okay, so HODI high, so tan x plus 1, secant x tan, minus high, secant x, d host, derivative of tangent would just be secant squared, over tan x plus 1, the whole thing squared. Okay, so that's what we should have gotten for our first line in the derivative. Everything else is algebra and trig and simplification. Okay, that's the derivative piece. And so let's start simplifying. Wait a minute, I missed my middle term. Hold on. Okay, so looking at that, you're like, I'm not sure any of that's going to help me. Always start with factoring because my hope is to eventually be able to reduce something in the denominator, okay? Is there anything or any term that's a part of everything in the numerator? Secant, okay? So let's pull a secant out. Now, here's the tricky part. All right, we're still looking for, is there some kind of identity? I noticed that I have a tan squared in there, I have a secant squared in there, and there is a trig identity. It's Pythagorean. All right, so I'm going to put it over here in a thought bubble. Okay, Anybody remember that identity? Tangent squared plus 1 is secant squared. So could I manipulate it so that I had the tangent and the secant together? Yes. All right. If we did that, okay, if I pull the secant squared over, that would give me what? Tan squared minus secant squared equals -1. Does that work? Okay. That would work. Or could we just replace the secant squared with tan squared plus 1? Yeah, and that's probably what I would do. Okay, so I'm going to use this identity and replace the secant squared. So it's going to give me secant x tan squared plus tan minus, and I'm going to plug that identity in, tan squared plus 1. Okay, all over tan x plus 1 quantity squared. Okay, so all I did was just replace that secant squared. I did it on purpose because now what's going to happen to my tan squares? They're going to cancel out. Okay, so my tan squares are gone, so I'm left with a secant x times a tan x minus 1 over tan x plus 1 quantity squared. And that's as simple as that will go. Okay? It'd been nice if something could have reduced, but it didn't. All right? We just weren't that lucky. Okay? But recognizing those, all right? If you look at some of the solution manuals for some of these as you're working on, this is where sometimes I'll get to the end and I'm like, how come my answer doesn't match what's in the book? Because I've done all the steps are the same. It's probably a trig identity somewhere in there, okay? That's always a good opportunity. Then I use PhotoMath sometimes for that, just so I can see where was that trig identity that I missed, okay? Just kind of a learning process. The good news is they're not going to ask you to do a plain derivative like this in a free response and get down to a most simplified answer. Multiple choice is where you're going to see these, all right? So you will know how far to keep going. So that's kind of nice. It will lead you, all right, to where it wants you to go, all right? Question about that one. So it was one we had to do quotient rule because there were multiple terms in the denominator, okay? All right, let's look at one more, then we're going to call it done for the day. Okay. So this one wants me to find f prime. The one thing I notice about this one is even though it's a fraction, there's a product in the denominator. And a lot of times when there's a product, I can rewrite and simplify those, and it makes my life a little bit easier. Okay? So let's mess with that just a second. All right, let's rewrite. Tangent is the same thing as sine over cosine. And then cosecant is 1 over sine. These are all y's. Okay. So my denominator is going to reduce a little bit. And so that leaves me sine divided by 1 over cosine. Okay. Or it's just sine times cosine. All right. And so I can do this one with the product rule. All right. Product rule is simpler than the quotient rule. So first times derivative of the second plus second times derivative of the first. So that gives me negative sine squared plus cosine squared, or cosine squared minus sine squared. That is an identity. Does anybody remember it? It's a double angle. It's okay if you don't. I'd leave it that right there too. Yeah, it's a double angle, but I would leave it right there. Cosine squared minus sine squared. Okay. Right. So practice a few of these, okay, because they're getting more involved, all right? And when we jump into chapter 3 or unit 3, it's where derivatives get real involved, all right? So there's just a lot of stuff that's going to happen. Your lesson practice is out of the text today, all right? So it starts on page 152 and goes a little bit further. So 1, 3, 5, 6, 9, 10, 22, 29, 31. Okay. Quiz tomorrow. Just sections 5 through 9. So be sure and study. All right. If you've not done any of that homework or practice, go back and do some of that. All right. Make sure you understand that. And then you can go ahead and click your wrap up on Google Classroom and get that done for today.